In this video, we'll talk through the National 5 Unit 1 topic of calculations involving the mole and balanced equations. At the end of this video, you should be able to calculate the formula mass or gram formula mass of a substance, be able to perform calculations using the relationship between the mass and number of moles of a substance, and be able to perform calculations from balanced equations. Formula mass of an element or a compound is the sum of the masses of all the atoms that it contains. If we take something like helium, which exists as a single atom, its mass will just be 4 atomic mass units. The relative atomic masses can be found on page 7 of the data booklet. The table has the elements arranged in alphabetical order by name, and we're looking at the third column within the table to give us our values we will be using. If you were asked to calculate the formula mass of hydrogen, we have to be aware that hydrogen is a diatomic element, therefore it exists as H2. That means that we have got 2 hydrogen atoms. Each hydrogen atom has a relative atomic mass of 1, therefore the formula mass of hydrogen would be 2 atomic mass units. If we do a similar thing for sodium chloride's formula is NaCl. This means that we've got 1 sodium atom, which means it has a mass of 1 times 23, and we have 1 chlorine, which has a relative atomic mass of 35.5. Adding those two together gets you a formula mass of 58.5. We're asked which of the following substances has the smallest formula mass. All we need to do is just walk through each of them in turn. For carbon monoxide, we have 1 carbon and 1 oxygen. Carbon has a relative atomic mass of 12. Oxygen has a relative atomic mass of 16. 12 and 16 gives us a total formula mass of 28. If we then look at carbon dioxide, we have 1 carbon and 2 oxygens. That's 1 times 12 for the carbon, and 2 times 16 for the oxygen, giving us a total of 44 atomic mass units. Nitrogen, diatomic, we have 2 nitrogen atoms. Each of the nitrogen atom has a relative atomic mass of 14, giving us 28 atomic mass units. And for methane or CH4, we have 1 carbon, which has a mass of 12, and 4 hydrogens, each with a mass of 1. Adding them together gives you a formula mass of 16. We want the smallest value, meaning that D would be our correct answer in this question. Next, we're going to talk about the mole, and we're not talking about the furry little creatures. We are talking about a unit in chemistry. The mole is a way of measuring the quantity of a substance. It's a convenient way of counting atoms, and this allows us to make predictions about the masses of different substances that are involved in reactions. It leads us on to the gram formula mass, which is the version of formula mass we're more likely to be asked to use. The gram formula mass of a substance is known as 1 mole, and it's its formula mass expressed in grams. If we talk about carbon dioxide has a formula mass of 44 atomic mass units. Its gram formula mass would be 44 grams per mole. This means that if we have 1 mole of carbon dioxide, we will have a mass of 44 grams. This leads us to a relationship that becomes very important in our calculations. That relationship is N equals M divided by GFM. You can find this on page 3 of the data booklet. The N stands for number of moles, the M is for mass of the substance, and GFM is for the gram formula mass. We might be asked to calculate a number of moles of a substance when given the mass that we have got. We're asked about number of moles, which is N. We're given a mass in grams, which is our M. We can work out the GFM of a chemical as long as we either know or can work out the formula of that chemical. Carbon dioxide is CO2, which means we've got 1 carbon, which would have a mass of 12, 2 oxygens, which gives us 2 16s, which are 32. Together gives us 44 grams for every mole. We can then use our relationship of N equals M divided by GFM, giving us 22 over 44, giving us 0.5 moles as our answer. We could be asked to rearrange that relationship in order to work out the mass of a substance. In this question, we're asked to calculate the mass of 3 moles of sodium chloride. We're given our number of moles. We're asked to work out our mass. We're given a formula, meaning we can work out the formula mass. We have got 1 sodium, 1 chlorine, giving us a formula mass of 58.5 atomic mass units, which also means that our GFM would be 58.5 grams per mole. If N equals M divided by GFM, we're going to rearrange this to give us the M equals N times GFM, plug in our numbers of 3 times 58.5, gives us an answer of 175.5 grams. Could be asked to calculate the GFM. In this question, we're told that 8 moles of a substance has a mass of 500 grams, and we're asked to work out its gram formula mass. We know N equals 8 moles, M equals 500 grams. We're asked to work out our GFM. If N equals M divided by GFM, then GFM equals M divided by N. This means that it's 500 divided by 8, which gives us a GFM of 62.5 grams per mole. Here we have a typical exam style question. We're told some information about a particular chemical, in this case sodium percarbonate. We're asked how many moles there are in 1.57 grams of sodium percarbonate. In this question, they have given us the formula mass being 157, meaning we do not have to work it out for ourselves. We are asked to work out our moles. The question tells us that the mass is 1.57 grams. We are told that our formula mass is 157. Therefore, N equals M divided by GFM, which is 1.57 divided by 157, which, when you put it in your calculator, gives you 0.01 moles as our answer. In this question, we're asked about the mass of ammonia present in 0.1 moles of ammonia. Look at what we're given. So we're given our number of moles. We want to work out our mass. We can work out the GFM. 1 nitrogen has a mass of 14. We have 3 hydrogens, which is 3 times 1, giving us a formula mass of 17. Our GFM then 17 grams per mole. From the data booklet, it tells us that N equals M divided by GFM, which means M equals N times GFM, which would be 0.1 times 17, giving us 1.7 grams, which matches to answer A. In this question, we are told a number of moles of gas, and we're told the mass that that number of moles has, 12.8, and we're asked which of the following could be the molecular formula for the gas. We know our N, we know our M, that means we can work out our GFM. So N equals M divided by GFM, so GFM equals M over N. This gives us 12.8 divided by 0.2, giving us a GFM of 64 grams per mole. We can then go through each of the options and see which of these has a formula mass equal to 64. Sulfur and oxygen, we have 1 sulfur, which is 32, 2 oxygens, which gives you 32. Added together gives you 64 grams per mole. Follow it through just to make sure we're doing the right thing. Carbon monoxide, CO, would have 1 carbon of 12, 1 oxygen of 16, giving you 28 grams per mole. Onto carbon dioxide, we have 1 carbon, which is 12, 2 16s for the oxygen, which gives us 32, total 44. And our ammonia, NH3, we have 1 nitrogen, which is 14. We have 3 hydrogens, each being 1, giving you a total of 17 grams per mole, meaning that our answer matches up to A. It's also possible to use a balanced equation to work out how much product is produced or how much of a reactant is required. Balancing numbers or stoichiometry indicate the relative number of moles of each substance involved. For example, if we're talking about magnesium burning an oxygen to produce magnesium oxide, our balanced equation is 2Mg plus O2 goes to 2MgO. This means that 2 moles of magnesium reacts with 1 mole of oxygen to produce 2 moles of magnesium oxide. In this question, we're asked to calculate the mass of magnesium oxide produced when 49 grams of magnesium completely burns. We'll start off looking at the chemical which we're told the mass of at the start, which is magnesium. We don't know the number of moles. We know the mass is 49 from the question. We can work out the GFM as we've done before, giving us a GFM of 24.5 grams per mole. We can then work out the number of moles this relates to. You're doing M divided by GFM, or 49 divided by 24.5, giving us 2 moles of magnesium. If we then look at our molar ratio, we can see that our ratio is a 2 to 2 mole ratio, because the balancing numbers in front of both are both 2. This means that there will be the same number of moles of magnesium oxide produced as magnesium we start with. We've calculated that we have 2 moles of magnesium, which means we will produce 2 moles of magnesium oxide. Next, we'll need to work out the GFM of magnesium oxide. We have 1 magnesium, which is a mass of 24.5, and we have 1 oxygen, which is a mass of 16, giving us a GFM is 40.5 grams per mole. We can then use our relationship from the data booklet, which says N equals M divided by GFM. Therefore, M equals N times GFM. That gives us 2 times 40.5, giving us an answer of 81 grams of magnesium oxide will be produced. In this question, we've been given information about nitrogen trifluoride. We're asked to calculate the mass of nitrogen trifluoride produced from 7 grams of nitrogen. We're going to start with the nitrogen because we're given a mass of it in the question. Our number of moles we don't know, but the mass is 7 grams. We can then work out our GFM, which is 2 times 14 for the 2 nitrogen atoms, giving us 28 grams per mole. We can then use N equals M divided by GFM, which would be 7 divided by 28, giving us an answer of 0.25 moles. We're now going to compare the number of moles in our balanced equation of the 2 chemicals, those being N2 and then the NF3. The nitrogen trifluoride, the name tells us that it's NF3 with the trifluoride part. It also says that it's the mass that is produced. This means it will have to be after our arrow in our balanced equation. Our ratio this time is going to be a 1 to 2 ratio. There's no number in front of the N2, this means it's a 1, and there is a 2 in front of the NF3. If we had 1 mole of nitrogen, we would make 2 moles of nitrogen trifluoride. From what we have calculated in the first part of our question, we have only got 0.25 moles. This means that we'll make 0.5 moles of NF3. We can then move this forward into the last part to get our final answer. We now know the number of moles. We're asked to calculate the mass. We've got 1 nitrogen, which is 1 times 14. We have 3 fluorines, which is 3 times 19, giving us 57. Total being 71 grams per mole. Now that we have this information, we can use N equals M divided by GFM, which can be rearranged to be M equals N times GFM, which is 0.5 times 71, giving us our final answer of 35.5 grams of nitrogen trifluoride being produced. In this question, we're told information about ammonium sulfate and asked about ammonium carbonate. We're going to start with ammonium sulfate as we're told the mass that we are using for ammonium sulfate. We are going to convert our kilograms into grams by timesing by 1,000. We can also then work out our GFM of ammonium sulfate. We've got more parts to this, so there's 4 different elements involved in this compound. And there's brackets involved, so we need to consider how many nitrogens are inside the bracket and also which number is outside of the bracket. So we have got 1 nitrogen on the inside of the bracket with a 2 on the outside, meaning we times it by 2. This means we've got 2 nitrogens in our compound. That gives us 2 times 14, which is 28. We then have 8 hydrogens, 4 on the inside, times by the 2 on the outside of the bracket, giving us 8. 8 times 1 is just 8. 1 sulfur has a mass of 32, and 4 oxygens, each with 16, gives you 64. Add them all together, gives you 132 grams per mole. Next thing we do is use N equals M divided by GFM, giving us 13,200 divided by 132. This gives us 100 moles of ammonium sulfate. We will then compare the ratio of ammonium carbonate to ammonium sulfate. We've got a 1-to-1 ratio, which means that because we have 100 moles of ammonium sulfate, we will make 100 moles of ammonium carbonate. In order to work out the mass that corresponds to, we have to work out the gram formula mass of ammonium carbonate. We again have 2 nitrogen, which is 2 times 14. We have again 8 hydrogens, which gives us 8 times 1. 1 carbon, which is 12. 3 oxygens, 3 16s are 48. In total, that gives you 96 grams per mole. We can then go on to finish off this question by using a rearranged N equals M over GFM. That gives us M equals N times GFM. M equals 100 times 96, giving you 9,600 grams or 9.6 kilograms. In our final question, we're asked about ammonia and ammonium phosphate. We're asked to calculate the mass of ammonium phosphate that would be produced from 510 grams of ammonia. We're going to start off with ammonia because we're given our mass in the question. We are going to work out the number of moles. To do so, we need the GFM. 1 nitrogen is 14. Hydrogen, 3 ones are 3, giving us a GFM of 17 grams per mole. Use N equals M over GFM. 510 divided by 17 gives you 30 moles. Onto our molar ratio, comparing ammonia to ammonium phosphate. This is a 3-to-1 ratio. Therefore, our 30 moles of ammonia corresponds to 10 moles of ammonium phosphate. In order to work out what mass this corresponds to, we'll have to work out the GFM. We've got 3 nitrogens, which are 3 14s, giving you 42. We have 12 hydrogens, 12 times 1 is 12. 1 phosphorus, which is 1 times 31. And 4 oxygens, 4 16s are 64. This gives us a total GFM of 149 grams per mole. We're going to use N equals M divided by GFM. We'll rearrange it to give us M equals N times GFM. Therefore, our mass would be 10 times 149, giving us 1,490 grams. Hopefully now by the end of this video, you're able to calculate the mass or gram formula mass of a substance, perform calculations using the relationship between mass and the number of moles, N equals M divided by GFM, and be able to perform calculations from balanced equations. Thank you for watching. Goodbye.